Hello viewers, welcome to this video lecture series on reinforcement learning. Reinforcement learning is the advanced category of machine learning. It builds its prediction model by gaining feedback from random trial and error and leveraging insight from the previous iterations. If you compare with supervised learning and unsupervised learning, in supervised learning you were giving what the labeled data, whereas for unsupervised learning you are giving unlabeled data. But how this reinforcement learning works is, it is going to work only with the trial and error. It starts carrying out its task. Okay, the moment it sees that the task is not getting completed or it is not about to reach to the goal, then it is going to get a feedback, and it will learn from the previous mistakes and it will try to take a better action next time. So every time it takes an action, it will get a reward. The reward can be positive or the reward can be negative. Before I show you one diagram to make you understand reinforcement learning, look at this statement. The goal of reinforcement learning is to achieve a specific output by randomly trialing a vast number of input combinations and grading their performance. Here algorithms are set to train the model based on continuous learning. Now this is what you have to remember. Actually here you are training the model based on continuous learning. Example for reinforcement learning, you can take self-driving cars. So the score becomes positive if the car is avoiding a crash. You can take another example, chess, positive assessment if defeats are avoided. In order to understand this reinforcement learning, consider this diagram. You should be knowing about these terms. We have agent, environment, action, state and reward. See, as I said, reinforcement learning is what? Learning by trial and error. So in a particular game, when the agent is there, when the AI agent is there, when the AI agent is playing the game, so the agent is facing one environment. The AI agent is the player now. So let me take the example of gaming only for reinforcement learning. So this agent or this player is what is in some environment, and it is going to take the action to reach to the goal, and it will be in one of the state any point of time in the game. If at all it is taking an action which is always resulting in a reward, then it will get the feedback as the reward. If the action taken by the player is not making the player to reach to the goal, then it will get a negative reward. So these are the different terms that you should be knowing here for reinforcement. Agent is the learner or the decision maker. Environment is everything the agent interacts with. Action is all the possible moves the agent can make. State, a situation the agent finds itself within the environment. What is reward? A feedback signal. After each action, the agent receive a reward or penalty, which is a numerical score to learn what is good and bad. Now the reward can be positive or negative. Negative reward is what? It is a punishment. When the rewards are more, the behavior gets reinforced and learning becomes possible. So one example you can check here with the grid game. Here is the AI agent. Let us take this agent has to move towards the goal. The goal is here. So the agent has got various paths to reach to the goal. Suppose if it takes a path like this, it is moving towards the danger. So first time when it moves here, it may get a reward, but second time when it is trying to move to this, it is falling into danger. It is a negative reward here. It is a punishment. So the next trial it will do is what? It will try to go in this manner, and when it goes to this, it is facing a block. Once again it is a penalty here. So next trial it will take in this manner. It will get a reward at every action it takes. Finally it reaches to the goal. So this way the AI agent could reach the goal after several trials. In every trial it comes or it faces some obstacle, and it will learn from this obstacle. That means next time it is going to avoid that route. So it will learn from the previous iterations and try to improve in the next iteration. The different algorithms that comes under reinforcement learning are Markov decision process, Bellman equation, dynamic programming, value iteration, policy iteration, Q-learning. These are the different applications of the reinforcement learning. Automated robots. Reinforcement learning based robots learn through trial and error to optimize the performance. So as you know that nowadays robots are used in every field. So how they are going to carry out their job? It is they are learning by the trial and error method. Natural language processing is one of the applications. So it will improve machine translation, then question and answering, and predictive text. Marketing and advertising. So by looking into the customer's behavior. Gaming, as I already said, the performance can be improved by repeatedly playing. Traffic control. The traditional mechanism is having certain fixed rules for the traffic, but here you can see that it can dynamically learn and adapt the changing traffic conditions in the real time. Recommendation systems. improves recommendation systems for services like Amazon and Netflix. This point I have been telling from the introductory chapter that recommendation system is one of the popular application of machine learning. So here when you are trying to buy a particular item from Amazon, it is going to recommend you similar items. You're watching a show on Netflix, it is going to recommend you similar type of shows. Now as we have completed the topics on supervised, unsupervised and reinforcement learning, you can always just see here the comparison, taking the comparison only with respect to three headings: input, output and methodology. So let us take for supervised learning, input is known, output is known. That means you are giving the label data. The dependent variables are also mentioned there. So it analyzes combinations of known inputs and outputs to predict future outputs based on the new input data. Unsupervised learning, you are giving the unlabeled data. You're not going to give the values for the dependent variables. So that means output is analyzes inputs to generate an output. Algorithms may differ from data mining. Reinforcement learning, you are not going to give any input here, okay? So but output is known. That means the goal for that player is known here. What is the goal in that particular application is known here. So randomly trials a high number of input variables to produce a desired output. So it keeps itself trying what with different input combinations to produce the desired output. So this is all about the reinforcement learning in this session. Hope you find this session helpful. Please like, share and subscribe to my channel. Thank you. Bye bye and take care.